Hello everyone. In this video, we're going to look at another example of data integration. This video is going to focus on data redundancy challenge of data reduction. Of course, as we saw before, entity identification problem is still going to play a role normally in all of the data integration problems or like projects that you may have. So we're going to see another example, and we will see how we can use our analytic tools to go about dealing with this example of data integration. So let's get to it. So the data that we're going to be using for this lab is going to be a data set from kaggle.com. It's a solar panel generation data. So basically the source of data, there are two types of data here we want to integrate here. We have generation data and also sensor data. So the generation data comes from 22 inventors, and these inventors are basically what you see in a solar panel, those black surfaces that absorb the energy from the sun and they invert it to electricity. And then you have a sensor data that's basically calculating the temperature or other things about the environment. So you have these 22 inverters and one sensor. And you would like to see in the 34 days that this data was collected, if there are some relationship, if there is a relationship between the temperature and power generation, if there is a relationship between irradiation and power generation, and also if there is a relationship between temperature and irradiation. So as always, the first thing we will do is we are going to import our module. So we import our module, and then first we look at the generation data. You will see in the generation data we have the date time, plant ID, source key, the amount of DC power, AC power, daily yield, and total yield. And so the DC yield, amount of the DC power generated by that inventor. These are the keys of those inventors. And then AC power the same, but for AC. And then total yield and daily yield are basically the cumulative sum of power generated on that day. And the total yield is like the amount of power that has been generated by that inventor. So let's go ahead and first check how many source key we have here. So let's go ahead and say, and then we want to look at the source key, and we want to see how many unique values. So we should be having around, 22 inventors. And if we count these, there are 22 of them here. So we don't really need the plant ID because the plant ID is the same for all of them. As you can see, the plant ID is only one. And we don't really need the daily yield and total yield because we are only going to see the relationship between temperature in the time, in that moment, or in a span of time, and the amount of electricity that's being produced. So we don't really need the daily yield or the total yield. So we also drop those. So the next thing we have done here, we want to see if these two are really different values, the AC power or DC power. Once we do the scatter plot, we see they're almost identical because they have the same relationship, or their correlation is very high. Basically, they are sort of completely predictable based on one another. And we can also see that in the correlation coefficient. So we can just only focus on one of them. And that's another example of data redundancy. Even though there are two completely separate columns, they have a very, they have basically the same information. When we talk about information in the area of data mining, information is variation across the populations of data objects. And the variations across the populations of data objects for AC power and DC power are almost identical. And because of that, we don't really have any new information based on these two columns. So we might as well just drop one of them. So we go ahead and drop the DC power and we keep AC power. So now we only have the AC power for these sources. The next thing we want to do, we want to like calculate the amount of electricity that was created on each time, and we want to like sum up all of those inventors. So there were like 22 inventors, if you remember. So these are like 22 inventors. We want to like have one number for that specific time frame. So the way we have done this, we have done a group by based on their date time, and we calculate the AC power. So for each date time, there's going to be 24 source key, and it's just going to sum up all of those values for it. So once we run this, now we have a series that have these date times as the index, and then the amount of electricity that's been produced. So we can sort of like switch that into a data frame. We can call our data frame generation df by making sure that it looks like a data frame, so it's better accessible. And then we can go ahead and also plot this as to sort of like take a look at how our data looks like. So we can see this is our data basically, and every day, so there should be 34 of these sort of like spikes, and every day as the sun comes out, your electricity start working. You're going to start building electricity, and then the sun comes down. During the nighttime, there's not going to be any sun, so there's not going to be any generation. So if you count these spikes, there should be 34. And so this is sort of like we were able to clean one source of our data. So the second source of our data is the sensor data. Comes from the weather sensor data. So once we run this, now this has a couple of different values here. It has ambient temperature, module temperature, and irradiation. So the ambient temperature, this is the ambient temperature at the plant. This is what was the temperature in the plant. Then there is a module temperature attached to the solar panel. So one of the solar panel had this sensor attached to it. So this is the temperature reading from that specific module. And then irradiation is the amount of irradiation for the 15 minutes interval of that sensor. So we go ahead and see if there is different source keys here. And once we do this, we see only there is one source key. It means that there is only one sensor in this data. How about plant ID? The plant ID is also the same. So we can go ahead and drop these values because they're all the same. So let's see if ambient temperature and module temperature have a lot of differences between them. What is the relationship with them? So we use the scatter plot and correlation analysis. So in the correlation analysis, we see they have around 85% correlation, which is a high correlation, and we could sort of like see that correlation between them. So we want to sort of like see the relationship between temperature and generation of data. But between these two, they're very similar, but there are also differences between them. But which one should we choose, or which one should we keep? That's another sort of challenges of data redundancy. So the way you go about choosing what to keep is basically seeing which one of these two columns are going to be more helpful for your analysis. So here we can sort of see which one of these two columns have more relationship with the irradiation, and that one is more connected to power generation column from the other data source. So based on this analysis, we can like choose the one that is closer to irradiation. So we go ahead and check which one is closer to irradiation. So either the module temperature or the ambient temperature. So we do the same analysis for both of them. We do the scatter plot with irradiation ambient temperature is around 72 correlation. They are highly correlated. I mean, it's above 70%. And we can also see that in the scatter plot. But the correlation between irradiation and module temperature is like much higher. So because of this analysis, because we want to see the connection between temperature and the power generation, and sort of irradiation is sort of like in between, we keep the module temperature. So we go ahead and drop the ambient temperature. So now we have this data set. And also we want to be able to connect this or like join this to the other data frame, the data source that we were looking at, which was the generation df. So we have datetime here, we have these values, and for the generation data, we want to just go ahead and join these values. So we have the generation df, and also we have the sensor df. So we want to like integrate these data frames. So we go ahead and try to integrate or join them. But we see there is something going on that's not working out here. And if you look at the format of datetime for sensor data and format of datetime for the generation data, you see that there is a difference between the formatting of the representation of the dates here. So for you to be able to integrate Pandas data frame, you have to make sure that the indexes are using the same format, and not only they are representing the same day, but also they're presented with the same format. So to deal with this, we change the datetime formatting of sensor df to the generation df. So we create a function that we are going to apply to the datetime of the sensor df. So we get the year, month, and day based on that format, and then we reformat it based on the way it is shown in the generation df. So we create this function, and then we apply this to the sensor df datetime. And after we've done that, now the sensor df datetime looks exactly like the generation df datetime. So now they have the same formatting. So now that we have this, now we can go ahead and set this as our index, and now if we join them, now it's going to work for us. So now we can simply do a correlation analysis and also scatter plot analysis and answer the 3 questions that were asked, that we had to integrate these 2 data to be able to answer them. So we see that here the AC power is highly correlated to irradiation. It's also highly correlated to the module temperature, but it's not as much as it was to the irradiation. We can also do the correlation analysis, like scatter plot analysis. We can see all of them are very connected. So the answer to all of those questions is simply yes. The temperature and also irradiation predicts the amount of power generated, but also temperature predicts the amount of irradiation.